So I am giving the tree diagram for this problem. I already gave the answer for this problem 1 by 3 2006, total 25 calculators, and in this 2 defective, 23 non-defective. ND stands for non-defective. From this we are selecting 5 calculators. In these 5 calculators inspected, the only one calculator to be defective. So 1 defective, others should be 4 defective. This is the tree diagram. Okay, then you check the answer 1 by 3 is correct or not. The next one is (2009) 2 marks. Unbalanced die with 6 faces, comma, numbered from 1 to 6 is thrown. Full stop. The probability that the face value is odd is 90% of the probability that the face value is even. The probability of getting an even numbered face is the same. Full stop. If the probability that the face is even, given that is greater than 3 is 0.75, comma, which one of the following options is closest to the probability that the face value exceeds 3 question mark. So first of all I am denoting, let O denotes face value is odd and E denote face value is even. Then what is the data given from the probability face value odd? P of O is equal to 90% times probability of even. Okay. So that means this simplifies to 0.9 times P of E. But on the dice only even and odd number, one half of equal in nature, 1, 2, 1, 3, 5 odd numbers, 2, 4, 6 even. Since probability of odd face value plus probability of even face value, these are only the mutual exclusive cases, okay, is equal to 1. So this becomes, substitute P of O there, 1.9 times P of E is equal to 1, which implies P of E is equal to 1 by 1.9, 0.6253, check that value, correct or not? Sorry, 5263. 5263. 1 upon 1.9. And what is given? Probability of getting even numbered face is same. Okay. Probability of 2 is equal to probability of 4 is equal to probability of 6 is equal to x. Say given probability of even face is same. And say this is equation 1, probability of even we got. Now see. Now 1 implies what is even 2 or 4 or 6, 3 cases. In that 2, 4, 6 all are mutual exclusive. So probability of A or B or C is nothing but in the case of mutual exclusive, which I have discussed in the last class, P of 2 plus P of 4 plus P of 6. Okay. That is given here 0.5263. Now because of each is given same, even face value is same, so this becomes 3x is equal to 0.5263, x is equal to by 3, 0.1754, please check. And finally what is given? If the probability that the face value is even, given that is greater than 3 is, okay, P of face value is even, given that face greater than 3, this value is 0.75. Okay, so using conditional probability, this becomes even face intersection face greater than 3 comparing with P of A given B divided by P of face greater than 3 is equal to 0.75. And the Question requires which one of the following options closer to the probability that the face value exceed 3. Face value exceed 3 means greater than 3. That means in this step we need to find the denominator. Now, what is numerator? Even face means 2, 4, 6. Intersection face greater than 3 means 4, 5, 6. 4, 5, 6, 2, 4, 6. Intersection is P of 4 or 6. That means 4 plus P of 6 divided by P of face greater than 3 is equal to 0.75. Which implies P of face exceed 3, that is greater than 3, is equal to 0.75 divided by 2x, because P of 4, P of 6, P of 2 all are equal to, I said, x. What we got? X value? X value is 0.17. So this is 0.75 divided by 2 times 0.1754. Calculate this value. So this is approximately equal to 0.468 according to the options. Of course, I didn't give the options here. Since even face is equal to set to 2, 4, 6, okay, face greater than 3, nothing but 4, 5, 6. What is the intersection of these two sets? 4 and 6 only. P of 4 plus P of 6. One more problem, last problem on this basics. This is given 2 marks, 2012. A fair coin is tossed till a head appears for the first time, full stop. The probability that the number of required tosses, comma, is now here a coin is tossed. Our requirement is getting head first time. That means if one time tossed, if head will fall, then game is over. Otherwise, you have to repeat the game until to get the head first time. That means if the second time toss, you may get tail. If the third time toss, you may get tail. We don't know where do we stop until, but we know where do we stop means until to reach or to get the head first time. But in which number of required tosses getting first time head? Odd number of tosses. What is the odd number of tosses means? First time tossing, third time tossing, fifth time tossing, etc. In any of these, the question is required that getting head first time. The question is required getting first head time, getting head first time in odd number of tosses means first, third, fifth toss, etc. Solution. Probability of getting head first time in the odd number of tosses. This is we required. This is nothing but P of probability of getting head first time in first or third or fifth etc. tosses or occasions. That means probability of head or TTH or TTTH in these occasions or etc. See, suppose first time gets head, that means probability of head. If first time not getting head, then we have to play up to third time. So that means first time giving tail, second time giving tail, then in which game it first time head falls, third time only. If third time also falls tail, then at which time again first time gets head, fifth time only. Okay, that is the meaning. So this is 1 by 2. So in the 3 times tossing a coin, the coming out this outcome, probability of this outcome is 1 by 2 into 1 by 2, 1 by 8. Okay, 1 by 2. This tossing a tail, getting a tail, getting a head, each is equal to same chance. And this 1 by 2, 1 by 2, 1 by 2, 1 by 2, 1 by 2 plus etc. See, the meaning of is first time tossing a coin, if head appears, no problem. If head does not appear, then what is going to fall? Tail. Then again we look for getting head first time in which toss? Third toss. That means we are concentrating third time getting a head first time means the first two tosses shows tails only. That is TTH. Suppose if the third time also gives tail, then we look for getting a head first time in the fifth tossing a coin. That means all the previous 4 tosses gives tails. That is TTTH, like that. So in all this, I can take 1 by 2 common and the remaining 1 plus 1 by 4 plus 1 by 4 whole square I can put like this, geometric series, infinite geometric series. But we know that here I am giving formula, since 1 plus x square plus x cube plus this is equal to 1 divided by 1 minus x, that is 1 divided by 1 minus x if minus 1 less than x less than 1. This is infinite geometric progression where x is the common ratio. So this is 1 by 2 into 1 by 1 minus 1 by 4. So this simplifies to 2 by 3 answer. Next important topic is Bayes theorem. Generally, this is difficult understanding in statement itself. Mathematical definitions are, maximum definitions in mathematics are difficult to understand in the beginning stage only. After giving or solving or doing any problem, then we will compare each sentence available in the definition or theorem with that problem. Then we can easily understand. Okay? Write the statement. Suppose E1, E2, comma, E3, comma, so on, En are N mutually exclusive and exhaustive events of the sample space S and A is any arbitrary event of S then the conditional probability of EI for I is equal to 1, 2, so on N given A, comma, is given by P of EI given A is equal to P of EI into P of A given EI divided by summation I is equal to 1 to N P of EI into P of A given EI for I is equal to 1, 2, so on N, and P of A is equal to summation I is equal to 1 to N, separately denoted the denominator by P of A. P of EI into P of A given EI, after expanding, this is giving 1 by 1 value to I, P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus so on plus P of En into P of A given En is called total probability. First you write down, then I will explain, but it is difficult to understand without example this theorem. After that example, then it is very useful and very important also. Very easy, very useful, very important also.